Hello. In this video, I'll be showing you four things. So initially, I'll be going through how I've used Blender for designing the environment and the robot. Blender is a 3D graphics and animation software, and so you don't really need to design the environment and robot because MOS, which is a robotic simulator library, provides you many common robots and environment platforms. But according to our requirements, I've designed the environment and robot. Then, as I said, like MOS is a robotic simulator, so you could like import the Blender designs, and you can add actuators and sensors to the robot. MOS itself does provide many commonly used sensors and actuators, so you don't really need to do it. And then it does provide you some interaction, default interaction, so you could like make the robot interact in the environment. So I'll be showing you that. Then the third thing that I'll be going through would be like a wall falling demo in which the robot is just starting from the center and going along the walls. And the fourth demo is occupancy grid, where we'll be seeing that where the robot has explored in the environment. So okay, so let's look at the environment first. Robot simulator. Okay. So this is how the environment looks like. It's just like four walls. So four cuboids have been merged, and then there's a plane at the bottom. So that's all. And to make sure that the robot doesn't go through the walls, you've got to select add passive for the rigid body, and this is it. Then let's look at how the robot looks like. So yes, so it just looks like iRobot. It's a slender, and the green lines here show you the collision boundary of the object. So here in collision bounds, it's been selected as cylinder, and also you have to select in the physics property as rigid body, and you've got to select actor so that it collides properly with the walls and objects that you have been selected as passive or active. Then I've changed the mass so it has a proper gravity, and that's all. I've not added any sensors and actuators. That would be done through the MOS library. So this is just designing the body of the robot. So okay, now let me start the MOS environment. So it's loading. So this, you can see the robot inside the four walls. Now here you could see that there's a small camera in the center, and this shows you what the camera is looking at. And this is just for debugging purposes, just to know what's in front of the robot. It's not being processed, and I'm pressing the keyboard keys to make the robot rotate around, and then and it goes forwards, backwards, and left and right. Okay, fine. And this is done through coding. Like, you've just got to add that keyboard interface, and yes, you can control it. And some of the default options are provided as well, so you could change, and these options are like mostly for changing the position of the camera. So you could have just four rooms, it could be expanded and you want to look in a certain direction, so it gives you that control. So if I press control, and you could like go up and down, you could W S A D R F. So you could like switch between the cameras if I had multiple cameras, and many other things. So this, oh sorry, H. Okay, yeah. So okay, now let me show the wall following. logic. So here you can see that there are 3 infrared sensors around the robot, and using that, it's actually following the walls. Actually see here. So it's not really so precise in the sense that it doesn't follow it properly. Actually, it should just go in one single line. So I've got to like adjust the values. Now if I show you from the beginning, you could actually see properly. So let me just start that again. It has some problems in the initial start that it's not going so close. So I've got to set the values properly. So first let me adjust the camera. Okay. Um, okay, I think that's fine. So we'll start then. So it's going straight. You can't see the other wall, but you've got to imagine that it's there. So you can actually see, okay, there's like some distance and it's not properly rotated. So, and then it's like from that time onwards, it's like a bit of a problem. So the reason being is just that I'm just using the infrared sensors. I've got to actually add some wheel encoders so I know how much the robot has actually rotated. Though I could rely on the infrared sensors if I add another one at an angle of 45. So that's in between the one in the center and the one on the right. That could be useful, and I'm planning to use machine learning algorithm to actually get the proper values. Now here it's become, okay, it's not stuck. It's just that it just stays there for some time. So I've got to like really understand like why that's happening. But it's a really simple program. It's not really complicated. So, but yes, even though it's not so complicated, it's giving a very complex nature. Okay, so let me show the last demo of occupancy grid. So as you can actually see that the robot has a camera. Now the same position I've placed a pose sensor. So that's for actually tracking where the robot is and what all the robot has explored. So if I just stop this demo and start it from the beginning. So I won't be controlling it through that program, but um, I'll be using the keyboard, and we'll be seeing like what all places the robot has explored through the pose sensor, sorry. And the pose sensor is placed just at the exact position the camera is placed. So, oh, okay, sorry, there's a problem. There's a bug. I'm so sorry. So I'll just solve that. Yep. So this is the thing. So if I just keep it here, maybe that'd be better. Okay, so that's going behind. The only way is like I have to switch between the two. Otherwise, it's not possible for me to show both of them. So okay, fine. So let me go in this way and this way. So if I just go there, you can see. So I've not like made it the same size of the room because we really don't know how the room looks like. So I've just given a specific size, but in reality this could be of any size. Now this is the real map of the world being explored by the robot. And okay, so let me just explore some more. So okay, So we just go straight, then take a turn and go right ahead. So let's see that here. So you can actually see it's quite precise because I'm using the sensor data. Now the aim is actually to create the same map without the camera and without the pulse sensor, but just using the infrared sensors and maybe wheel encoders. So this is the actual data, and the robot will make its own map. Now this map which is created here using the pulse sensor will be compared with the one created with the robot, so we know how precise the mapping of the robot is. And then we could use this map which is created by the robot in real time for like many AI algorithms like tree search, reinforcement, learning, many other things. So yeah, so this is what all I've done. Hope you liked it.